Welcome to today's Dynamo Office Hours community conversation. We are here with Jacob and Sol again when they have a couple of special guests today. We'll get into introducing everybody in just a couple of minutes here. There's just a few slides that I have to quickly go through. So yeah. Again, welcome. So community conversations. If this is your first time joining us, basically community conversations are put on by the Autodesk community, and we get expert speakers from around the community and within Autodesk as well to come and share their knowledge, make connections with all of you who are, joining the calls and things like that. And it's always hosted by someone from the Autodesk community team. And that would be myself. So yeah, that's kind of what community conversations are if you are new to this. Next slide is our safe harbor statement. This is basically stating, please do not make any purchasing or future decisions based on anything that is talked about in this conversation today. Just don't let it affect any of your decisions moving forward with products and things like that. So I'll give you guys a chance to read it. We'll pause on the slide for a minute and I will take a peek in the chat and see where some people are coming from. We've got Sweden and the Netherlands. I think those are some of the furthest I see at least. So welcome. California. I always get tripped up when I see Jacob's Boston because I always go, oh, wow, you guys, someone's so close. And it's Jacob and Sol. But anyways, so that is the safe harbor statement. Onto the next slide, which is where I will introduce myself and then hand it over to our speakers today. So I am Tiana. I am a community program manager here at Autodesk. I am based in Manchester, New Hampshire. And I have a couple of dogs that might make appearances or sounds during this, so I apologize ahead of time. And I will hand it over to Jacob and Sol.
Thanks. So I am Jacob Small. I'm a technical consultant for Autodesk, background in architecture and specialist in generative design and Dynamo stuff. You'll find me doing whatever I can to help anybody I can on the Dynamo forum as often as I can. So I describe myself as a Dynamo forum junkie based out of Boston. Sol.
Hello, everyone. My name is Sol. I'm product manager working on Dynamo, originally from New Zealand. So if I see something that sounds weird, let me know. Happy to translate those slang words. I am based here in Boston as well, but I have lived in Scotland and England and Canada before this. And I describe myself as a curious human being because I like everything about everything and want to dip my toe in every water that I can find. On to you, Kean.
Thanks, Sol. So my name is Kean Walmsley. I'm based in Switzerland, working for Autodesk Research. I've been in a lot of different teams. So some of you may have, I may have worked with you or come across you when I was in the developer network team for many years. I was a software architect on the AutoCAD team for some years as well. And for the last 6 or so, 7 years, I've been working in research with Rhys on things like the space analysis package and Vasa. So some Dynamo related stuff, some generative design, some stuff for using Autodesk platform services as well. I describe myself as a social animal, which is only half true. I didn't really know what to put, mainly because of the blog and Twitter and stuff like that, but not, anyway. I'll hand it over to Rhys.
Yeah, hi, I'm Rhys Goldstein, also from Autodesk Research. I study space analysis and computer simulation and how they can be applied to building design. I developed some of the core algorithms between a couple of the packages that we're talking today. And yeah, looking forward to it.
So just before they get into the meat and potatoes of all of this, just a couple of things. We love to see the reactions when they are presenting and things like that. This is a conversation. We want you guys to be engaged and things like just show your excitement. There you go, Sol. And then on top of that too, we also have the chat available. So if you have any questions or comments as we're going along, please feel free to drop them in the chat. You also can raise your hand and we will take you off mute if you have any questions that you want to ask anybody at any time. And just as a heads up, I guess, this is recording. The session is recording and it will be posted on the Community Conversations event page, which is where you were to register for this event. And you'll be able to rewatch it, as well as it will be available on YouTube. So yeah, without further ado, kick it off.
All right, thanks, Tiana. Welcome everybody to the Dynamo Office Hours series. This is session number 43. Autodeskers, packages of note. I didn't update this page. Essentially, we're going to talk about some really cool things that exist in the world of Dynamo that you don't quite get out of the box, but you can find easily on the Dynamo Package Manager. This doesn't mean that there's not awesome non-Autodesker packages out there of note. There's plenty of those, and hopefully in the future we get to talk about a handful of them. For today, this is either packages that have been created by people on this call or in-house or affiliated with Autodesk through something like a contract. So we're excited to show you the functionality, the power that some of these packages bring to enable yet more awesome workflows in Dynamo. So as usual, our agenda is roughly like this. We're going to do about a 20-minute presentation on packages of note. We're going to have a live demonstration today helmed by Kean and Rhys. They're each going to talk about one of the respective packages here, space analysis and Vasa. And then we have a Q&A, but please do interrupt us. Like, we want this to be a conversation. We're more than happy to stop and answer questions at any point in time. It doesn't, we prefer it to be that way as opposed to, say, just talking for an hour and then getting a few questions at the end. So to start, we're going to go through a handful of different packages in presentation format, and then we're going to do the live demo at the tail end. So first one we want to talk about today is the Dynamo Future File package. If you've heard about this, you probably know what it does. And if you haven't, we're going to explain a little bit about that today. So essentially, Dynamo has a way of distributing itself. We build these things called daily builds. We have stable versions of those, and then those get consumed in host applications like Revit and Civil 3D. And that is at a slower cadence because those host applications don't release as much as we do. And then sometimes we have problems that sort of creep out into the Dynamo ecosystem that we want to resolve faster than that cadence happens, or they might happen in an older version of Dynamo that we want to resolve through this means. And that's where the Dynamo Future File was born. It's essentially an extension that you can download and install. You're not going to see anything in the UI, but it's going to be there working in the background that allows versions from older versions of Dynamo to essentially talk nicely to newer versions of Dynamo around things like file format changes. This is a way for us to get it out to you quicker than making a patch release, which requires us jumping through a few hoops, and also allows us to get fixes out that don't meet the minimum bar or requirements for us to do one of those bigger releases. If you are a developer who work on Dynamo and you find something that you don't think is cool and you want it to behave in a different way, we are welcoming PRs to this extension. And so please do send PRs. There's a link here for the GitHub repo. It's called Dynamo Future File. It's all public. You can see what goes on there too. There's also, as you see on the right-hand side, a forum post for a little bit more context around this from Mike Kirshner. So feel free to go and have a read about that if you want to see more of what is happening with the Future File.
All right, and on to the next one, ye old snake, Python. So IronPython 2 package, it's incredibly popular, but before we start to get into that, let's talk a little bit about the history and why it's there. So Dynamo's original Python engine is the IronPython engine. Effectively, this had to go away in Dynamo 2.13 for security reasons. And the reason for this was Python 2.7, which that IronPython implementation was built upon, is no longer supported. It's been end of life, therefore it's not getting any security updates, therefore it's a risk. And since we don't want to ship risks into everybody's environment, we pulled it out. Once that had been done, meant we needed a new Python engine, and that's where our newer CPython 3 engine came into play. This utilizes Python 3 plus. Currently, I believe we're looking at 3.9 with 2.17, and there are previous builds that were, I believe, 3.8, but don't quote me on that. I might be slightly wrong. I might even have gone back to 3.7 at one point. So The big difference here is IronPython is a .NET implementation of Python, and CPython is a C implementation of Python. You will have the CPython implementation from Dynamo 2.7 and on. There's a whole bunch of benefits to that, including faster runtimes, better package support, better performance, and more portable code. The stuff that you write from Dynamo will be able to be utilized on other stuff. I was actually writing Python, taking some Python I'd written in Dynamo and working on it on my iPad the other day, which was kind of fun. So yeah, we can really start to move stuff back and forth. And there's a lot of stuff that comes with this. Now, again, this has been out there for quite some time as sort of a thing that was coming in terms of the migration. You can see we got this blog post dating back to 2021. So we've got a couple years worth of sort of history in there and all sorts of tools to sort of help you do that migration. Now, one thing to note about that is, well, if it's so simple and it's so much better, everyone's just going to probably switch over to the CPython 3 engine and just be done with it. We can just end this conversation, right? Well, yes, except you're going to find that far too often the APIs that you need to access are going to be sort of buried behind some sort of 8-ball. You're not going to be able to get directly from where you are to where you want to be. This is particularly problematic on the Civil 3D side of things. And let's talk a little bit about why. So right now, we all know that we sort of write our Python code something like this. You can see I've written this using the CPython 3 engine. This code does actually execute. It does some cool stuff. Feel free to grab a screenshot and type it up while listening here. But basically, this is the software architecture of your computer over there on the right. We've got the hardware up at the top, right? That executes the machine code. Then below that, the machine code actually has this next level of software in there, C, right? C is typically where your OS kernel and a few other sort of core, really low-level software implementations start to happen. On top of that, we came up with a new language, C++, right? And then on top of that, we finally came up with C# and the .NET. Now, all the software that we use, Dynamo, Revit, Civil 3D, previously IronPython, is all happening in .NET, but our CPython implementation is happening much closer to the hardware, closer to the bare bones. And so as a result, there's all this extra translation. We've got to cross a couple of those dashed red lines, which tends to slow stuff down and cause some issues. So it's not always a direct one-to-one sort of translation. So how do we recommend sort of people get through there? Well, my advice, if I'm doing a Dynamo interaction and it's just working with the Dynamo sort of core library, I always start with CPython. I've yet to find an instance where I can't go straight through standard Dynamo geometry kernel or geometry calls using CPython. They might, not to say they're not out there, but I haven't come across one yet. For Revit interaction, I always start with my CPython and then go back to IronPython if I have to. Right, and typically that's going to be around stuff like forcing transaction content, where you might need to sort of have an extra class in there to deal with your error handling and stuff like that. On the civil side of things, I typically just go ahead and start with IronPython. And again, the reason for that, too many of the core utilities in our typical boilerplate code just doesn't work in the CPython implementation. So something to keep in mind. All right. Enough about Python. Let's talk about Mesh Toolkit. Sol.
Meshes, awesome. All right, so you may be aware or not aware of like different styles or types of geometry that exist. So you have things like surfaces and you have things like solids, which kind of behave the way that you would think based on their names. And we have another class of geometry called meshes. And so this is rampant through things like the games industry. And this is like a representation of geometrical form with polygons, so essentially triangles. And what you can see on screen here is some of those in action. So meshes consist of particular topological pieces such as vertices and edges and faces. And these are ways to derive relationships and understand how these sort of triangles relate to each other and how to sort of traverse those triangles. But the cool thing to call out here is that they're lighter than solids and surfaces. So when you're working with meshes in the context of Dynamo or anywhere else, you would essentially be working in a faster way using meshes. So because meshes are lighter, they're much faster to work with, which is great, but they have some limitations to them as well. So for example, we have a mesh implementation of Dynamo out of the box that's very, very basic. And that very basic mesh implementation can be used and do good things. But we also have a package called the Mesh Toolkit, which the slide is about here. And what that does is it extends the capability of meshes and allows you to do more awesome things. However, two meshes, or both of these meshes, are not created equal in some ways. You can't actually work with them directly to each other. They require a translation between them. And the node that is created by the community, so shout out to Dimitar Venkov from the Springs package, to do that is this mesh.to2tk mesh, or mesh toolkit mesh. And what that does simply is actually just reorganizes the data points on how these triangles are essentially created. So meshes also don't behave very well with the other functionality for things like surfaces and solids, which kind of makes sense. You know, if you're trying to do something on a solid or a surface, you need to work with solid or surface functions. And meshes have their own functions. So in this case here, on the bottom of the screen, if you're trying to find the area of a mesh, you're going to need to use a specific node to do that. In this case, mesh area, rather than something like surface area. So if we go to the next slide, you see just a couple of funky mesh operations, which you may or may not be familiar with. So we have the ability to essentially reduce or facet in some ways meshes. So it goes from being a relatively sort of smooth sphinx on the left-hand side to a more polygonal one, which is what you saw on the previous scheme. Also, you can do things that you can do with solids and surfaces like intersection algorithms, which is kind of fun. And then there's a handful of nodes at the bottom that allow you to do things that the solids and surfaces may be able to do, but meshes can probably do better, which is the ability to do things like making them hollow for 3D printing, closing their cracks, remeshing them, repairing them, and so on. A bunch of functions that do really cool things, and they're definitely worth playing with.
And the next package is Pattern Toolkit. It's all about repetition. The cool thing with Pattern Toolkit, it basically allows you to take sort of any sort of 2D pattern and even images and map them over a surface to get patterns that will just sort of repeat there. Once you have the pattern sort of applied to a surface, you can start to deform it, upscale it, and otherwise alter the pattern or individual instances within the pattern to sort of drive alterations to your downstream geometry creation. After you've applied all your alterations, you can then go ahead and sort of bring over your actual geometry elements as either 2D or 3D geometry instances. There's a way to sort of make individual shapes, like you can see at the top there. I wanted to make a bunch of hexagons in a hexagon pattern. Well, we can say polygon by and sides from pattern point, and it will actually follow that surface, which is pretty cool. You can also use images to deform stuff. So as I did here, I actually scaled up in the lower left-hand corner in the red circle there, or lower portion of the screen rather, in the red square, you can see we've got the Dynamo logo, where I've actually pulled the RGB values of each one of the colors to sort of deform the shape of the individual circles, as well as change the color of the circles, which is pretty cool.
Hey, Jacob, I think we just lost your clarity on your voice.
Okay.
Second, yeah, that's better. We're back.
All right.
Cool. So we also have a simple but fun and effective package called Dynamo Text, which allows you to do things like spread messages, which is great stuff. In essence, actually have some text inside of Dynamo Graph or the Dynamo window. It's very basic. It uses the Arial font. If you wanted to go and rebuild this package, we do have the GitHub repo there. You can probably change some variables like the font choice and so on. But the basic out of the box one does what you see on screen, which is taking a point, which is the insertion point of that text, allows you to choose any kind of text you want to represent there and the scale of that text on your screen. The thing to be aware of is in the code block or a string node as your input for that text, it will adhere to formatting. So feel free to use things like new lines and returns in that. But what comes back, because it is so simple, is individual lines. So if you're looking to do something like close those lines into, say, a polyline, and then maybe extrude them through a surface thickening operation or something, you'll need to actually do those downstream operations with more nodes to get there. And the somewhat tricky thing is figuring out how to cut the holes out of that stuff. Something we could improve in the future if we need to make this much faster. But today it is basic and it does the job of giving you information on screen. And
the next package we're going to talk about is solar analysis, right? Because our geometry deserves a tan too. So effectively what this package does is it allows you to calculate the solar insolation values for a given surface, including shading surfaces, location, time, and sample resolution. Basically, you're going to get sort of the cumulative average and peak insolation values in watt hours per meter squared, if my metric is correct there. But yeah, from there, you can go ahead and just take those initial sort of schematic level calculations in the context of generative design to do stuff like quickly evaluate where the hotspot's going to be in my park that you see here. We've got a whole bunch of topography that's actually fairly steep, not the best screenshot, but that's why we see a lot of stuff that's kind of sitting in shade and shadows where we might, or cool spots where we might not think they might be. But the cool thing with this is it takes a really complex issue of sort of calculating where are we sort of collecting the most solar heat and where do we need to mitigate that very readily, which makes it great for generative design.
Cool, Jacob, we've got a couple of questions in the chat. So Patrick asked, is it possible to insert patterns in Civil 3D? Kean already answered that. Oh, sorry, you already answered that. Yes, want to call that one out though. You can, it's in the core, you can use anything. So you can use it in Civil 3D to make some awesome surface patternings if you want to have some funky, road operations happening or tunnel operations going on, which is cool. And we have another question, which is, can you make a poly surface from alias into a mesh to apply textures, since Dynamo doesn't work very well with many different NURB surfaces from alias?
No, because the pattern toolkit node actually requires a sort of surface for the mapping. It doesn't sort of match up to the meshes. And that's, again, sort of the difference between those two. There are other ways that you can make the multiple NURB surfaces sort of work. There was a great presentation at AU last year about Dynamo Player and Alias, and they snuck in some really cool information about multi-patterning, patterning across multiple surfaces for NURB surfaces, which does a pretty good job on that. That was from Michael Gunther Gepfers, and I'm sorry for getting your name wrong, Michael, if you catch the recording, but I'll see if I can pull that open and post it in the chat.
Awesome. All right, we have another package called the Refinery Toolkit. So this Refinery was the original name for what has now turned into generative design in Revit. And this is back when it was a package inside of Dynamo called the Refinery package. And there's a toolkit that's been created around that. So these are fancy tools in a fancy toolbox. So what you see on screen right now is a handful of different GIFs or GIFs, depending on your flavor of how that sounds, that do some really cool things. And so you can use this suite of tools to do out-of-the-box Dynamo things, even though it is largely focused on generative design workflows. You can use it just as standard Dynamo stuff if you want to. It is useful across the board to do things like generating buildings really quickly, generating site context really quickly, analyzing adjacencies and openness and pathfinding and visibility. Some of that overlaps with space analysis and the Vasa package, which we're going to talk about soon. Doing things like using a contrast focused color range. So if you know that you want to color, say, 20 different things and you want those things to look different from each other, you can just simply input 20 and it'll give you 20 colors that are the most contrasty away from each other that it can find, which is great. It helps instead of you having to pick them, unless you really like choosing colors, and then that's up to you. And there's also some cool stuff in there like bin packing algorithms. So if you want to fit a certain amount of rectangles in a bigger rectangle, like a moving truck, I think somebody we talked to in the past had used this to actually help them move house, trying to figure out if things would fit into the side of a truck. You can use this. It's really cool. Some of the nodes that were in this package, which is now sort of, I think, 3 odd years old, but still works great, have now been expressed inside of Dynamo Core out of the box, but maybe in a slightly different way. So one of those examples is there's a node here in this package called listshuffle.seeded shuffle, which is a way to get the same shuffling to happen again and again. So if you use a seeded shuffle, you will get the same results every time. That is now essentially upgraded all of the out of the box shuffling nodes in Core anyway. So that one might be slightly redundant, but everything else is definitely viable and good. And so if you go onto the generativedesign.org website, which is essentially the primer for generative design, you'll be able to see all of the sample files and download the graphs and play with them that you see the GIFs coming from here on the right-hand side. And they do really cool things like, spacing out trees inside of a space. You can do that randomly. We can start to think about proximity, and that auto-generating in blue here, a building form if you want to do some baseline analysis to it, or starting to figure out how to best optimize placing views on a sheet in the lower corner.
All right. And next up, this one is not really well known, but it is a personal favorite of mine. I've had a lot of fun with this over the years. I haven't ever actually gone so far as to really take it to the nth degree and pop something on a printer and cut it out, but maybe someday. This is Dynamo Unfold. It allows you to unfold really complex things down into something that you might be able to fit on a sheet of paper, print, and do some origami with. Basically, it'll take your planar faces and break them down into foldable topology, which can then be sort of used to model making and all sorts of other analysis, which is pretty cool. You can even go ahead and add the tabs so that you have stuff to glue with. Faces can be tagged, so you know exactly which face is which on both your original shape as well as the sort of unfolded piece. And what's really cool about this is the fact that it allows you to work with not just the actual surfaces, but you can also work with the topology as well. So if you just pull the face, again, that's the Dynamo reference to the surface as opposed to the surface itself. That will allow you to sort of process these much quicker and again, get phenomenal results, which is pretty cool. All right, on to space analysis.
Okay, so I'll take over for the next couple of slides. So space analysis package was really born as part of a project that we were working on relating to the Toronto office in Autodesk Toronto office in the Mars district of Toronto. So we often, we use this as a showcase for some of our research around generative design. And one of the things we needed to build in order to enable that was a 2D package that would allow us to do pathfinding, allow us to do visibility. We don't know if we actually used it for acoustics in the end, but we decided to build in acoustics as well because Rhys sort of found that with the algorithm that he implemented, he could do some sort of approximations related to acoustics as well. So it's a very lightweight 2D grid-based implementation. It has the same kind of core data structure that is used for these 3 different types of analysis. So you specify the resolution for the grid that you want to cover your space with. You add barriers that can be affected by, that can affect the pathfinding, but perhaps not visibility, for example. So you might have, pathfinding where you have barriers that stop you from walking through cube walls, but you may be able to see over the top of them. So you can basically choose the kind of barriers that you use for each of these different types of analysis, depending on your needs. So I'll give you a quick demo of this, but it'll be Rhys that demos Vasa later on. So on to Vasa, which is the next slide. And this is really where we took the capabilities, the core algorithms that had been implemented in space analysis and took them to the third dimension effectively. So looking at voxel-based representations, to a lightweight voxel-based representation that works for architectural spaces. Rhys implemented some really interesting algorithmic capabilities that dealt with optimized data structures using run length encoding and fancy stuff like that. Anyway, all very impressive capabilities that minimize memory but maximize performance. It's very much intended, once again, for pathfinding, visibility, and it can also be used for direct daylight as well. And with that, I'll probably switch across to demo. Is that the next slide?
Yeah, live demo.
All right. Oh, what could possibly go wrong?
Ominous danger music is called out specifically for that reason.
Perfect. So I will start sharing, and I'm going to share this. Hopefully you can see it okay. Great, yep. Perfect. So I'm going to run through a few samples. Let's start with the very basic sort of pathfinding sample. You can probably see from the tooltip there once the package is installed, there's an extra folder that includes these various sample files. So you need to kind of browse to the package folder inside the Dynamo Core, Dynamo Revit location, then you can load them from there. So this first pathfinding example is clearly the most simple. Well, let me see. Why have I? Okay, that looks okay. Perfect. Yeah, so here we go. You can see we've got a grid with a certain resolution. Now what we're actually seeing here is the start point and an end point, and you've got a just one barrier in between. All right. So in this case, we can go ahead and if I get the mode right, then I can modify one of these barriers, and we can see how the path is basically routed around it. In this case, it turns out it was shorter to go the other way than it was to keep going this way. Of course, we can also modify the start and end points as well. So it's easy to play around with the capabilities there. I'll look at a slightly more complicated one. Let's go down to pathfinding 3. Yeah, that's a good one. No, that's too much. Sorry, I went too far. Don't want to scare anybody. All right, let's go. Where was I? Ah, yes, I was further up. So pathfinding 3, pathfinding 2 is what I was looking for. So this is really just looking at one start point and then multiple endpoints. So we've got, once again, just one barrier. But here, if we sort of modify the barrier, we see the effect that it has on the pathfinding. Yeah, so the barrier is nowhere near now, so that's kind of the direct paths for each of them, but we can sort of really disrupt things and everything is routed around. Once again, you can kind of see some of the trade-offs in the sense of working with a grid-based. Oh, I didn't mean to move it that far. I thought I'd stop moving it. Anyway, but yeah, you can see some of the trade-offs here. Oh dear, and they see, I didn't mean to do that. Anyway, that's probably because I moved it way off the grid by mistake. So I'm going to have to restart that. The joys of live demos.
Yep, always happens.
Yes. Probably because I've been practicing as well. So I should maybe could have shut things down. All right, so let's move on from pathfinding to visibility. So let's look at how the visibility can work. So in this case, we'll look at the initial visibility sample. And in this case, it's quite interesting. Let's take a look here. So, well, actually, this is local visibility. So what we have is, you can see there's visibility within a certain area of the grid. In fact, what I'm going to do is open up the global visibility one, which is slightly more interesting because it fills out the whole of the grid. Now, in this particular case, if you look carefully, you can hopefully see that there's a couple of barriers in here. So there's one, and if I move that around, you'll get a sense for what's happening. So let's move that there. Now, this is the point that we're looking outwards from, essentially. That's what so if we move this around, we can start to see beyond the edges of those barriers, okay? You can also see, it's also limited by a certain distance. So what we can go into the graph itself and then look here where we're creating the visibility grid, that distance happens to be 10. If we reduce that down to 5, then we're going to see the distance that you're able to see, it shrinks effectively. But what we can also do is just get rid of that completely. So unwire that, and then we can see forever. Okay, so that's kind of how that works. And then we can, let's move this around a little bit more. Oh, yeah, sorry, wrong mode. There we go. Let's move it around that side. Okay, and that's it. Great. I think what we're seeing with this circle here is the extent to which an individual point in the grid is visible effectively. So as we get closer to it, or as we can see it perfectly well, the circle is larger. But if it's totally obscured, then it's much smaller. Okay. And then finally, let's take a look at acoustics. So there's a few different fun samples here. So let's go with the 1 point with global. All right, so here we go. So this looks kind of familiar to the last one in terms of the barriers. We can move the barriers around, and you can imagine this as an audio source, and this where we're kind of testing the level at an individual point. So once again, if we go a bit closer and where we don't have a barrier in between, then it's going to get louder. The circle is going to get larger. You can do things such as controlling the absorption of the various barriers. You can talk, essentially talk about the audio acoustics level as well. So there's a few things you can tweak there. Let's go ahead and take a look at another couple of samples. That was acoustics 2. Yeah, so this is two points here. So this is maybe an interesting, an interesting one to look at. So here we have 2 audio sources. If we move them around, then we can see how they how they interact with each other in terms of the combining. One thing we can do is also, we have inside this particular demo. So here, once again, this is what I talked about intensity. So we can reduce the intensity of the sound. We can essentially increase the absorption of the barriers. So there's a few things that we can tweak there. Now we can have them not absorb at all. And then the other thing that's possible to do is to, rather than do a union of sound, we kind of do an intersection. So it sort of, looks at the sound in a negative sense rather than a positive sense. Okay, so that I think is all I wanted to show for space analysis. Rhys, is there anything else you would like me to show while I'm here?
No, I think that's good. Yeah.
Okay, great. Well, with that then, I'll stop sharing and hand it over to Rhys to talk to you about Vasa.
Great, thanks, Kean. Hope I didn't. I just pressed the record button, so hopefully didn't mess that up. Let me share my screen.
No, you're good.
Okay. Okay. All right. So yes, this is Vasa. So again, this was sort of the 3-dimensional sort of version of space analysis that we did after, and this is the first sample that comes with the package. So I'll just quickly to run through this. What you're seeing here is the building that's been voxelized, kind of like in Minecraft, but at a higher resolution. So you can see most of the elements of the building there. I'm going to turn on the glazing, which we voxelized separately, and now we're displaying that with translucent voxels. Next, I'll turn on the shadow analysis. So this was analysis that's done in Vasa, and we actually do a direct sunlight analysis, but then we invert it to get the shadow voxels. And this is one of those analyses that makes a lot more sense in 3D than 2D. So this is not included in space analysis, but it is in Vasa. The next one is the visibility from a point. So this is very similar to what Kean showed in space analysis. We've got a point in the building, and then the green voxels are where you can see from that point out the windows, and you can see it's limited to a certain distance. But if we go into the graph, I'll try to find the right node. We can take that distance and we can increase it, or we can just disconnect it, and then you can see as far as possible from that point. And then next, we have the distance field. And so that's this is showing you all the places that a person could walk to within a certain distance from a point, and we're using that point there. So if I go in and find the right slider, I'm going to actually reduce that distance so that's just within, you know, about 5 meters. And then as we increase that, the distance field expands and it goes up the stairs and down the stairs, and goes out the door there. And then lastly, we have the path, which is the same as in space analysis, except it's 3 dimensions, so it can go upstairs and on slopes and things like that. So here's an example of a path. If we have time, I might just show one more example. I'm gonna show an example in Dynamo Revit.
We do.
Yeah, great. So I'll switch over to Dynamo Revit. And by the way, yeah, both examples are packaged with Vasa, but this one you'll have to get the latest version because we just released this example. It's number 14. But what we're seeing here is that the same building, but we're now it's being loaded directly from Revit. And then we've got some sliders that pick 2 points and does a path between the 2 points. So as we change the slider, it'll pick different points. We're actually using the door locations for the points, but it doesn't have to be the doors, but that's how this example works. And I'm just going to quickly show you some of the nodes that were used to make that work. So once you brought all your geometry in from Revit and have it organized, the first node you want to use from Vasa is this voxel model by geometry node. And the thing you really have to get right is this coarse voxel width parameter, which determines the size of the voxels. And so if you're doing a building analysis, to make it easy, we just recommend setting this to 1 meter or maybe 4 feet, but in this case, 1 meter, and you have to know what length units you're using in Revit. So we're using millimeters for this example. So we put 1000 in, 1000 millimeters is 1 meter, and that makes sure everything works. This node will actually produce a separate voxel model for each element in the building. So then you use a union operation, a Vasa union node, and that takes all those voxel models and turns them into one. Then you create a path model using Vasa, and that just determines which voxels a person could walk on in the building. And then you are ready to start creating paths. Now you create a path using the path model and the start and end point, and then choose how to display the path, in this case, just as a curve, and then we're coloring the curve. So those are the steps. Yeah, that's all I had.
Awesome. Thank you, Rhys and Kean. So lots of stuff shown. I think we've had a couple of use cases called out in the chat. But do we have any other questions? And if anyone wants to ask a question live, you're more than welcome to. And take you off mute. I think one thing to call out, which is very cool, is it's not that hard to use. There is a handful of nodes that are very obvious sequentially that you key together and you do some very powerful, very awesome things. And you'll notice that the interaction was relatively real time inside of Dynamo, moving the points around in both the 2D and the 3D versions. Some very fancy, clever things going on in the background. Nick is asking a question. So how does the voxelization handle small/detailed geometry?
Yeah, so you have the flexibility to create really small voxels if you want. So the options there is to make them, you know, whatever size. If you stick with the default and you put in the 1 meter where I showed, then you're going to end up with the default parameters, which has voxels that are 25 centimeters tall and 6.25 centimeters wide. So it's kind of a tall and narrow shape. And that will be good for pathfinding and for number of operations. But yeah, if you really want that fine detail, and maybe you're willing to limit the size of your model, then you can adjust the parameters so you get really small voxels in high resolution.
I guess my question is really more if you have additional small detailed sub elements, does voxelization ignore some of those in certain circumstances, or does that like bulk up your the size of the the overall element that you're getting?
Like so the Vox representation is, hopefully this answers the question, it's a binary 3D grid. So if you have a whole bunch of details just inside one voxel, it'll just become one voxel. So it's sort of all the details kind of get washed away, and that can be useful because sometimes you don't want those details. So it's actually nice sometimes. Like if you have a really detailed point cloud, sometimes you don't need all the details. So you can bring into Vasa and just get a voxel model instead, and not worry about that. But if you do want to preserve those details, then the only way to really do that is in Vasa is to make the boxes really small.
Gotcha. It's not going to simplify any geometry. It's going to take everything into account for like the element bounding box when it creates it. Okay.
I guess there's a follow-up question, I guess, from me, Rhys, to that. Can you have different sized voxels in the same model, or do they all have to be the same size?
Yeah, more or less the same size. There is it is designed to efficiently switch between different resolutions in the horizontal direction. It's kind of one of the more advanced features. So there's this there are these this is sort of this finest LOD parameter. LOD stands for level of detail, and you give that an integer, and so as you change integer, you quickly switch between different resolutions. If you want to get really detailed, you could probably use different resolutions together. There are some advanced features that help, but basically it's one voxel size for everything.
My experience with it has been to try and treat it as more of a schematic piece. It's less for finding sort of the fine level of detail. It's getting you on the right path with the pathfinding, as opposed to saying this is to the nearest millimeter the route that somebody's going to take.
Yeah, that conceptually parallels a lot of the rapid analyses in SpaceMaker. You know, you're directionally finding the path you want to take, and then later on you can validate the sort of reality of that. Adam saying, just keep thinking of it like Minecraft. Yep, makes very cool graphics. Anyone wants to play with them for that reason. Kean, question to you: have you tried doing your Wordle using voxels instead of the Townscaper?
Townscape? No, I might. I mean, my Wordle, yeah, my Wordle process is quite finely tuned at this stage, and it's all done from my bed. So maybe that's too much information, but I don't see that changing.
Fair enough. Fair enough.
Yeah.
So we have about 10 minutes left. We've got about 2 or 3 minutes of exit slides. If there's any other questions, please put them in the chat or put your hand up and come off mute to ask them. We have the creators of these packages here on the call. You know, if you want to get into the algorithm, potentially start thinking very deep, very technical, I'm sure we could have a very interesting discussion in 5 minutes about it. And if not, we can do the exit slides and get 5 or 6 minutes of our lives back. So on that note, and please do ask questions again in the chat. So we do have more upcoming sessions. So first of all, a big thank you, Kean and Rhys, to you both for coming today and presenting the awesome sort of space analysis and Vasa packages. I'm sure there's a lot of people in the call who are going to try them, and a lot of people who watch the YouTube link afterwards are going to try them out too. We have upcoming sessions. So again, a reminder, every couple of weeks, we do one of these sessions at Dynamo office hours. So the next 3 are going to be around Civil 3D specifically. So this is our second set on Civil 3D. First of all, we're going to be going with the flow, talking about pipes in Civil 3D with David Lacona. We're then going to talk about GIS and where in the world is my Dynamo with Anton Huizinga, who's going to be special guest on that one. And then blocking it out about created custom objects inside of Civil 3D with Zachary Jensen, who is repeating just like David is in the Civil 3D series. So please come along and check those ones out. If you're into Civil 3D or you're just curious, we'd be more than welcome to have you come hang.
So to me. So these are some of the ways that you can get involved in the community. We have a lot of different opportunities for you guys to get involved. We have socials as well as our forums. I don't know why I just blanked on that word, but as well as our forums. We also would love to see you guys get involved in community conversations and maybe host your own if you're willing to try it. That is also linked here as well. So yeah, hopefully we'll see you guys around in the community, and a reminder that this was recorded and the recording will be up. So if you guys have any questions that pop up after you have a chance to think about all the stuff you saw today, you can head over there and ask questions. And yeah.
All right, thanks everyone so much for coming today. Please do go ahead and play with them. Tell us what you think. Tell the authors what you think. Improvements can be made. Have these really good ideas that bubble up. So appreciate the time and hopefully see you in 2 weeks.